Okay, in this video I'd like to begin exercise 5b of the book Fundamental Applied Mathematics. We're on page 129 and the question is 1. It reads, a mule drags a felled tree of mass 500 kilograms by means of a horizontal rope. The coefficient of friction between the tree and the ground is 0.4 and the tension in the rope is 3 kilonewtons. Find the acceleration of the tree. The first thing we need to do is to draw a free body diagram. So we draw the horizontal, we draw our tree, and we know that there is a horizontal rope pulling the tree. We know that the mass of the tree is 500 kilos. 500 kilos, excuse me. Alright, so the first thing we're going to do is find out the forces on the tree in air, or forces on the tree in air. So if you picked up the tree and put it up here, what forces would there be on it? And somebody who's kind of switched on or realized I'm talking about the weight. So the sum of the forces is equal to mass by acceleration by Newton's third law. Alright, the acceleration we're talking about is gravity, which is in the j-hat direction like so. So we're going to find that the sum of the forces is equal to 500 g, that's its magnitude, but it's in a negative j-hat direction, and that's equal to the weight vector. That's when it's in air. They're the only forces acting on it in air. 500 g in a negative j direction. Like so. Next, of course, we know from Newton's third law, for every action there is an equal but opposite reaction. So the force of the tree on the earth, there is an opposite force, force of the earth on the tree. So that means there is a force this direction. This is called the normal force, and its magnitude is 500 g. And that's in a j-hat direction, like so. Equal in magnitude, opposite in direction. Next, we're told, and get rid of this, we're told that there is a coefficient of friction. Alright, so we're told that basically the ground doesn't want the tree to move. So it's the force of friction is in this direction. That's the force of friction. And we know that the force of friction is quite easy to work out. Alright, so let's see, are there any other, oh yeah, there is a tensional force here. The tensional force is 3000 newtons. That's T. Now, look at my video called the Massless Rope, because if you don't understand this, you will be preaching heresy, I suppose you could call it. So it turns out that if the rope is massless, and it doesn't say it in the question, then this tension here is also 300. Or 3000, excuse me. But if the rope has mass, that isn't the case. But look, we'll just leave it like that for the moment. So now what we need to do is apply some of our Newton's laws in order to work out what the overall force of all these vectors on the tree. Okay. Now the other thing we need to know, of course, is that the frictional force is equal to the coefficient of friction times the normal force. Okay, like this. So that's a very important thing. And we know that mu is equal to 0.4, like that. Alright, so let's work out what the frictional force is equal to. So we know the frictional force is a vector, and that's going to be equal to 0.4 times the normal force, which is 500, times 9.81, which is equal to the gravity vector. It's going to be in a negative I-hat direction, so we know that the frictional force is equal to, and we just plug it into our calculator, 0.4 multiplied by 9.81, multiply that by 500, and we get negative 1962 newtons in the I-hat direction. Alright, so I'm just going to get rid of this altogether and just write the frictional force is equal to negative 1962 I-hat. Alright, so that's pretty straightforward. So now we have all the forces acting on the body. So finally, we're going to apply Newton's second law, saying that the sum of the forces is equal to the mass times the acceleration. So the sum of the forces are, we have what? We have minus 1962 I-hat plus 300 I-hat, or excuse me, 3000 I-hat, we have plus 500 g j hat minus 500 g j hat is equal to the mass times the acceleration. Okay, of course these two just cancel out there. So we need to take 1962 from 3000, and we get an answer of 1038. So 1038 I hat is equal to the mass of the tree times the acceleration of the tree. Because you've got to remember, we're talking about the tree here, so this should be the sum of the forces on the tree. Alright, so what's the mass of the tree? It's equal to 500, so 1038 over 500 is equal to the acceleration of the tree. And let's just plug that into the calculator. And we're going to get an answer of 2.076. So we're going to say approximately 2 meters per second squared. Alright, so what I'm going to do is check that at the back of the book. So on 5B, question 1, 2.08, yeah, that's correct. So thanks for watching. Please pass it on to your friends and subscribe to my channel.